Hi everyone, happy Wednesday. It's Mrs. Warner coming to you live from my home. I have to be at home because my son's teacher got COVID and now the whole class is quarantined. Joyous. So anyway, here we are in my home. Maybe you can see my Christmas tree back there. Very exciting. And I hate to do this to you guys on a Wednesday, but we might not see each other for Thursday. Wouldn't that be fun? Because it seems like we might have a possible snow day. I'm so excited, people. I can't wait. Not that I can leave the house because I'm stuck at home, but that's okay. I'll still go outside and play in the snow. So today we're going to do some properties of rectangles, and I'm going to go through lesson 3.6 with you guys. I'll be filling in some stuff with you guys as we go. Here we go. Let's get at it. Okay, so properties of a rectangle. First of all, the rectangle falls under the parallelogram family. So it has all the properties of a parallelogram. So every single property that a parallelogram has, like opposite sides being parallel, opposite angles congruent, all sorts of that stuff will happen in a rectangle. And it has two additional properties. The main important property to make it a rectangle is that it contains 4 right angles. So if the rectangle has 4 right angles, or a parallelogram has 4 right angles, then it's a rectangle. And the other fun property is that the diagonals are equal in length or equal in measure. So if you were to draw the diagonals from corner to corner, they're going to be the same exact length. So let me just give you a little picture of our rectangle over here, freehand drawing it, super bad probably. And here would be our right angles. And technically, if you can find just one right angle in the parallelogram, then all 4 angles have to be right angles, because if you find one, you know if it's a parallelogram, then the opposites are equal to each other. So there's another right angle. And then you also know the property of a parallelogram, the consecutive angles are supplementary, so that forces these guys to also be 90 on there too. So technically you really only need one right angle to make a rectangle. Okay, so say we wanted to prove something is a rectangle. So there's a few different things that have to happen. The main important thing is that you first have to make sure that that rectangle is a parallelogram. That's because under our family tree, we had our quads at the top, and then there has to be either parallelograms or trapezoids. But in order to be a rectangle, it first has to be this parallelogram before it can be a rectangle. Same thing would happen with a rhombus, which we're going to do coming up, which might not even be until like next Tuesday that we do the rhombus, but that's a little crazy to me. Or the square would have to be all of these shapes first before it could actually be a square. So when we're proving something's a rectangle, you first need to prove that it's a parallelogram. And we did those proofs the other day together. So you can use any of your methods that you like to make the shape a parallelogram. And then to go that extra step and prove it's a rectangle, you could either show the diagonals are equal in length, and you would use the distance formula for that. Or you could show that the consecutive sides were perpendicular by using your slope formula, because if you use your slope formula, you can find that segments are negative reciprocal slopes, which then means they're perpendicular. And then if you have perpendicular lines, they form a right angle. Oh, coffee time. Look, I even have my holiday mug. Oh, there you go. Okay, so here we go. Let's look at the diagonal method first. So I'm going to show both methods. I'm going to show the diagonal method to make something a rectangle, and then I'm going to show the slope method. So it says quadrilateral Mike has such and such vertices, and use coordinate geometry to prove that Mike's a rectangle. All right. So if I'm using the diagonal method, the method with the diagonals that's easiest would be to use our midpoints of our diagonals to show that the two diagonals share that midpoint, making that a parallelogram. Because really, in order to be the rectangle, remember first, you have to make it a parallelogram. So when you read it, it looks like it's only one proof, but this is actually two proofs in one. I'm so excited. So I'm going to start out by doing the midpoint of my diagonals to make that shape really a parallelogram first, and then the rectangle. So I'm going to use my midpoint formula, which is midpoint. What do? Add them up and divide by 2. And I'm going to spare us all this agony of going through actually and plugging the numbers in. And I'm going to tell you guys that the midpoint of MK comes out to be 8 1/2. And the midpoint of IE is also going to come out to be 8 1/2. And if you don't trust me, you can plug the numbers in yourself and figure that out. But that would be what the midpoints actually come out to be. And you can see that they share the same midpoint. So I can actually write that conclusion. I'm going to put that, I'm going to run out of room, so I'm going to put a little therefore right here, right now, even though it's above that little spot. And if I know that they have the same diagonals, let me change this to a bigger font for you guys, sharing the same midpoint, I know I can make a concluding statement. So I'm going to say that MK and IE, oh, that's fun. It's typing an equation. That's fancy. Let me use a text box instead, people. What a hot mess today. Okay, here we go. So MK and IE share the same midpoint. Oh boy. Okay. So since they have the same midpoint, the diagonals bisect each other. So that means that Mike is a parallelogram, because if the diagonals of a quad bisect each other, then the quad is a parallelogram. So I know the proof said to prove a rectangle, but remember, because of that family chart up above here, in order to make something a rectangle, it first has to be a parallelogram. So I used my diagonals showing that they shared the same midpoint, and I came up with the conclusion. It sure enough is a parallelogram. Now, since it's a parallelogram, I can go that extra step further to try to prove it an actual rectangle. And so if I'm using the diagonal method, I would do the length of the diagonals, because in a rectangle, their lengths are going to be the same. So now I would be using the distance formula. And so the distance formula is the one with the square root, x2 minus x1 squared plus y2 minus y1 squared. And when I do my distance of m to k, again, I'm just going to write our answer for us. It comes out to be radical 65. And if I did my distance from I to e, it also comes out to be radical 65. And sure enough, that's exciting, because that means that the diagonals actually are equal in length. So now I can go and I can write my other conclusion. I can say that MK equals IE. The lengths of the diagonals are equal to each other. And since I know this, then I know that Mike is a rectangle. Because if the diagonals of a parallelogram, oh my, oh my Lord. Oh, Graham, are, look at my spelling, how bad is that? Are equal in measure, then the parallelogram is a rectangle. Here we go. Oh, does this have spell check? Heck yeah, people, don't you love that? Okay, so that would be my second conclusion on there, which is actually what I wanted to prove, and now that proof is complete. So I used the diagonal method to show that Mike was a parallelogram. Okay, now what if I wanted to use the slope method? That's fantastic. We love a good slope. We can use the slope method to do the same thing. So slope is y2 minus y1 over x2 minus x1. And remember, we still have to make it a parallelogram. So if we're using the slope method, our opposite sides are going to be parallel, and they're going to have the same exact slope. So like if I do the slope of mi, which I already did, it comes out to be 3/2. And then I did the slope of ik, and that came out to be -2/3. Now, they're not the same, but you might notice that they're actually negative reciprocals of each other, which is fantastic because I'm trying to make this thing a rectangle. And in order to be a rectangle, they have to have slopes that are negative reciprocals. So now I did the slope of ke next, and that came out to be 3/2. Wonderful, because now mi and ke are parallel, and then when I did m to e, me, it came out to be -2/3 for my slope. So that means that is also a negative reciprocal, and it's parallel to ik. So a whole bunch of different conclusions can happen here. I have to do the one to make it a parallelogram first, and then do the one to make it a rectangle. So to make it a parallelogram, I'm going to use the fact that mi is parallel to ke, and that ik is parallel to me. Okay, now I know that they're parallel because parallel lines have the same slope. You can't forget that statement because it's super important. Otherwise, your reader of your proof won't know how you knew those lines were parallel. You have to always justify everything. That's the whole point of the proof. So parallel lines have the same slope. So I know that Mike is a parallelogram because if both pairs of opposite sides of a quad are parallel, then the quad is a parallelogram. Fantastic. Now, remember, that's not totally what I needed to prove, but in order to make that shape a rectangle, it has to be a parallelogram first. And now you can look and you use your slopes. You can take any set that are consecutive or one side after another. So I'm going to say that, hang on a second. I'm going to say that mi is now perpendicular to ik. They're perpendicular because their slopes are negative reciprocals. And if they're negative reciprocal slopes, then there's going to be a right angle there. So perpendicular lines have negative reciprocal slopes. And perpendicular lines intersect to form right angles. So that means that Mike is a rectangle, because if a parallelogram contains a right angle, then the parallelogram is a rectangle. That was so much fun, people. So much fun. So I hope you enjoyed watching your fantastic rectangle notes. And I'm really sorry again to do this on a virtual Wednesday to you guys, but fingers crossed, that we have a snow day tomorrow because you guys need and deserve a break. Okay, I'll see you guys soon. Bye. Actually, if I don't see you Thursday, I won't see you till Tuesday. That's crazy. Bye, guys.